intersection? Do they both do the same? One did better or less? So I can make side-by-side box plot also. And how to make a side-by-side box plot? This side, let's say I use my 271.01. This side, I will use the information for my other section. And then I can see which one did better, which one did worse, or they both did the same. So stem plot are a good way to represent or to look for side-by-side comparisons also. But again, if you are working with larger data set, you are not going to make stem and leaf plot, then you work with histogram. Because for the larger data set, how many stems you will make? You will just keep on making. And if you just keep on making, it's a lot of work. So it's better to make a histogram. Let's say if I have 10,000 observations, I am now going to make a stem plot to find what is the representation of this stem plot using these 10,000 observations. Then I will use my histogram to read the pattern or what kind of distribution I'm working with. One more thing with the stem plot, sometimes we have a very small data set with 1, 2, or 3 stems. If we have only few stems, it's hard to see the shape of the distribution. So when we have only few stems, you can split the stem to make it a bigger stem plot. You can split the stem. You can split the stem to make it bigger. And how do you split? Let's say I have only this data set. If I'm looking for this data set, this is my stem 1 and this is my stem 2. So I have only 2 stems. So I have 1 and 2. So what I do, I will split this 1 and split this 2. And if I'm splitting these, which observation should go here and which observation should go here? Can I put any observation? No, then there is no point of splitting. So when we are splitting, we put 0 to 4. If my leaf has between 0 to 4, I will write here. If my leaf is between 5 to 9, I'll write it here. Same thing, 0 to 4 and 5 to 9. And let's see in our data set, what do we have? 0, this one, 2 will go here. 4 will go here. 9 is more than 4, so I will write 9 here. And 21 will go here, and these are more than 4, so I will write all this here. And when I make a histogram, this histogram is a little bit better than with just 2 bars. Now I have 4 bars. So again, you can split a stem plot if you have very few stems, but again, you have to follow this order. And here is an example. So here is an example. So leaf 0 to 4 would go on each upper stem and 5 to 9 would go on each lower stem. So here they have 15, 16, 17. So 0 to 4 will go here, 5 to 9 here, and same thing here. An example is of stem plot is given here also, so you can take a look. We did a simpler example. This is a little bit bigger, so I chose a simple example, but I'll suggest you to go over to get better idea. On histogram, we already talked, so there are the steps. For large data set and our quantitative variables that take many values, we use histogram. Divide the possible values into classes of intervals of equal width. We cannot do one interval 0 to 5 and next interval 10 to 15. So again, when you are dividing it, it will be divided into equal width. Count how many observations fall into each interval. Instead of counts, you can also use percentages. Draw a picture representing the distribution. Each bar height is equal to the number of observations in the interval. All right, histogram we talk. Okay, in any graph of data, look for the overall patterns. and for striking deviations. So when we are looking for the overall pattern of a histogram or a stem plot, we look for few things. First one is the shape of the distribution. Second one, how much time we have there? Second one is the center of the distribution. Third one is your spread. And fourth is the outlier. So when you're looking at the overall pattern of a histogram or a distribution, you are looking for these four things. The first thing is the shape. What should be the shape of the distribution that I'm working with? So I will use my data set, make a histogram or a stem plot, and look at the shape of the distribution. The shape will be either symmetric or non-symmetric. And we also call it skewed. When we are saying symmetric, it's the same as how we learned in our earlier courses in middle high school, axis of symmetry. So basically, which is like a roughly a mirror image. If you draw something like this and divide it into half, your left hand side will be approximately equal to your right hand side. For symmetry, left hand side will be exactly equal to the right hand side. So when you draw a line from the center, it divides into two equal halves. We are talking about symmetric. When it's not dividing into two equal halves, we are talking about non-symmetric or skewed distribution. Let's say if I have something like this, and if I divide, your left hand side is not same as your right hand side. You are dividing into half of your observations on the left, half of your observations on the right. But left hand side does not look exactly like right hand side. So this is called your skewed distribution. Excuse me. Sorry about that. You guys can see my screen now?
Yes.
Yes.
Yes. Thank you. So this is called your skewed distribution. And when we say skewed, we have two kinds of skewness. One is right skewed and one is left skewed. So when the tail of the distribution is going more towards the right side of the distribution, we call it right skewed. And when the tail, so like this is the tail of the distribution, let's say we start from here, and it goes more towards the right side, so we call it right skewed. And similarly, if you have something like this, and the tail of the distribution is going more towards the left, you call it left skewed distribution. So we are talking about shape as symmetric and non-symmetric. Symmetric, mirror image, or roughly the mirror image. Non-symmetric is skewed either to right or left direction depending upon which side your tail of the distribution is going more. So once you know the shape of the distribution, we look at the center of the distribution. So first part is important because you need to know what is the shape of the distribution that you are working with. Then only you can work with the center. For symmetric distribution, we prefer to work with mean as the center. And for non-symmetric distribution, we prefer to work median as the center of the distribution. And I will tell you in a little bit why. Mean is nothing. It is simply what we have learned before, average. And we all do calculate average at some point. If not much, we do calculate our GPA. So we add everything and divide with the total. That is your mean or average. So if you are calculating mean, we that average is your sum of observations, sum of all the observations divided with total observations. You guys able to read my handwriting?
Yeah.
Yes.
It's clear enough?
It's better than mine.
I know it's sloppy, so if you're not telling me, I'm thinking I'm perfect. So if at some point you cannot read, let me know. All right. So when we talk about mean, mean is nothing. You add everything, divide with the total. And let's take an example. Let's say I'm talking about this. So let's say my x is 2, 3, 4, 5, 6. And if I need to calculate the mean or average, it is 2 plus 3 plus 4 plus 5 plus 6. And how many observations I have? 1, 2, 3, 4, 5. And divide with the total. How much? 20 divided by 5, which is 4. So my mean or average is 4. Everybody good with that part? Mean is the sum of all the observation divided with the total. Nothing different what we have learned before. But when we are calculating median, again, both mean and median talks about the center, right? So half the observation above, half the observation below. If I look at here, mean is 4, and I can see that 2 observations above, 2 below. And when we are talking about median, median also talks about the center. So let's see what median is. So when we talk about median, median tells us, or you can say that mean gives us the balancing point when something is made of the solid material, where your actual balancing point is. Median tells us that the center with that is dividing into two equal halves, half observations on the left, half observations on the right. So when we are looking for the median, we use this formula to find the location of the median. Where is my median? So this does not give me the median. He gives me the location of the median in my ordered data set. So remember that ordered data set. When my data set is ordered, in this case, your data set is ordered 2, 3, 4, 5, 6. Sometimes you do not get the ordered data set. You get scrambled 6, 5, 2, 4, 3, 9, something like that. So first thing is organize that. For me, you do not need to do that. You just add everything. So it does not matter 6 comes first or 2 comes first. But when you are looking for the median, median gives me the center position. So if my data set is not organized, I will find or I will not find the correct center position. So n plus 1 by 2, n is your number of observation. In our case, n is 5. So I will look for median denoted with capital M. M is 5 plus 1 divided by 2, which is 3. So that gives me 3 is not my median. 3 is where, when I go on my order data set, the third position or in the data set is where my median is. So I will go back here and then I say 1, 2, 3. So my third is this. So my median is also 4. So both mean and median are same. When we talk about the center of the distribution, we say that mean is considered as the center of the distribution if the distribution is symmetric. So when both mean, we denote mean as x bar. When both mean and median are same, we say that the distribution is symmetric. When mean is greater than median or mean is less than median, the distribution is not symmetric. When mean is greater than median and mean is less than, how do we know which kind of distribution is? So let's make a little graph. And I told you that mean follows the tail of the distribution. If the tail is going on the right side, your mean is somewhere on the right side. Let's say this is the balancing point for this distribution. So this will be my mean and this is the median dividing into two equal half. Half of the observation, let's say I have 50 observations, 25 on my left side, 25 on my right side. So my mean is on the right side. And when we start our graph, we start from 0 and then keep on moving. So in this graph, we say that x bar is greater than your median. So x bar is greater than your median and the tail is following the right direction. So the distribution is right skewed. Sometimes you have no information about the data set. Only it is given that the mean of the distribution is 5 and the median of the distribution is 3.2. What do you say about the shape of the distribution? So you can say that mean, which is 5, is greater than 3.2. So if mean is greater than median, I am talking about skewed distribution, which is mean is higher, so right skewed. Same thing when you talk about mean is lower, then it is left skewed distribution. So these are the three properties that we use. And I am looking at the time. We have only 1 minute. So let me just do this and stop. So when we use symmetric distribution, since both mean and median are same uh, for symmetric distribution, I will talk about why do we use only mean as the center of this distribution, not median. So our fourth point is outlier. Outlier that lies outside your overall pattern is your outlier. So there are outliers in your data set that helps or that explains if their distribution is right skewed or left skewed. So let's say your data set is 2, 4, 6, 9, and all of a sudden you have 60. So I can see a pattern 2, 4, 6, 9. They are not far apart, but all of a sudden I have 60. So when I have this 60 instead of 6 or 10 or 12, that 60 will change my average a lot. So when we are talking about outlier in a data set, that outlier affects the mean, not the median. If I'm looking at the median is still my third position, which is 6. So median does not get affected by the outliers, but mean does get affected by the outliers. So that's why we use mean as the center when we work with symmetric distribution and median as the center for non-symmetric distribution because they do not get affected by the outliers. And it's past time, so I will stop here. And happy Friday, happy weekend. If you guys have any questions, let me know. I am still here for another 5 minutes. And sorry about taking an extra minute.
Thank you.
Thank you.
Thank you.
You're welcome.
Thanks.
I had a question.
Yes, just give me 1 second. Let me put the computer on charge. Yes, sir.
Is there a chance that we can get the notes from that you wrote on this presentation to like send out to the campus or no?
This presentation that I just did?
Yeah, with the year notes, like because I know we get the slides, like the blank slides, but like, is there a chance we can get the notes, like year notes?
These notes are so messy that I just did.
No.
Yeah, but I made chapter 1 notes, like I have handwritten chapter notes, so I'm going to upload those for at least for chapter.
Okay.
Yeah, I will do that.
Thank you.
But if you look at Stat 108 notes, you will find all the information there as well.
Okay, thank you.
You're welcome.
Yeah, have a good weekend.
You too, thanks.